Boom! Yes, folks, welcome again to another AdMaths video. Alright, now this video is an addendum to the series of videos where we would have discussed the equation of a circle. In the video prior to this, I would have more or less wrapped up the series of videos, but what I didn't do, there was one part that I forgot that I was supposed to do as part of this series. So I'll do it now as an addendum, right? And you now just have to take it as part of the overall consideration of the thing. So we would have had the standard form of the equation, which we would have expanded to get the general form. And the equation that we had was x minus 6 to be squared plus y minus 7 all to be squared is equal to 5 squared, where the center was the point 6,7 and the radius was 5. So now, having already gone through the general version where you have the general equation and you complete the square to get the standard form of the equation, what I will now do is use this actual example, right? We have the general form. I will take this equation, completely square in it, and then get the standard form of the same equation. All right, so the equation that I have here before me, yes, we're using the small board, right? We have the small board and the big board. Normally I'll use the big board when I doing more videos for my students, but right now there's just one video, so I wouldn't stress myself out to go and set up just to make one video. Let me take this, we have enough space here. So we have here the equation x squared minus 12x plus y squared minus 49y. Sorry, y squared minus 14y, my mistake. Y squared minus 14y plus 60 is equal to 0. So suppose we're in a situation where we have this equation to work with in an exam, or you're working out a worksheet or whatever it is. So you start with the general form, and for whatever reason you're required to change it to the standard form. Alright, so remember, to switch from general form to standard form, the technique is to complete the square. Alright, so again, no, I wrote this out the wrong way, man. Alright, let me write it out how it's supposed to be written. Hold on. It's supposed to be x squared plus y squared minus 12x minus 14y plus 60 is equal to 0. Alright? So even though I'm making this as a pre-recorded video, I will leave these segments in where I myself making one or two little mistakes in the course of putting it together, because that is what will happen in a real life class. So as close as possible, we simulate a real classroom. Alright? So this is what you would have to start with if you were in an exam or for whatever reason. So you get the general form, x squared plus y squared minus 12x minus 14y plus 6 is equal to 0. Now, let me discuss this here now. In the general form of the equation of a circle, invariably it will always boil down to x squared plus y squared. Reason being, you might get an equation, let us say for the sake of argument, you have an equation 2x squared plus 2y squared minus 19x plus 17y minus 45 is equal to 0. That is the equation of a circle. Alright, we're not going to bother ourselves with finding, we could do that as an exercise, right? We will do that as an exercise. We will do that as an exercise, alright? So, once you have it in this form, even though the coefficients are not, the coefficient here is 2 and the coefficient here is 2, This is the equation of a circle because we could divide the whole equation by 2 to get it in the general form. So in other words, the general form, the coefficient of x squared must be equal to 1 and the coefficient of y squared must be equal to 1. So even if you get an equation looking like this, you divide it by 2 and you end up with, watch it now, x squared plus y squared minus 19 over 2x plus 17 over 2y minus 45 over 2, right? Of course, as you would have guessed by now, I deliberately chose these numbers as odd numbers just to make the point that you could have, it doesn't matter what the coefficients here are. The coefficient of x here could be anything, positive, negative, fractional, rational, whatever, right? The coefficient of y here could be anything, fractional, rational, that sounds nice, fractional, rational, integer, positive, negative, whatever. So too for the constant, same thing. The restriction though is on the coefficient of x squared and the coefficient of y squared. These two must be equal to 1 before you could go into any of the normal things that you could do. So for example, you're not going to come here and say that the coefficient of x is minus 19. No. The coefficient, the x coordinate of the center. Remember, we would have discussed that in a previous video. We're not going to say, for example, that if we say that the coefficient, I get my words mixed up. If we say that the coordinates of the center are p, q, we're not going to come here and say that 2p is equal to, we're not going to come here and say that minus 2p is equal to minus 19. We're not going to come there and say that minus 2q is equal to 17. No. Cannot do that at all. Alright? Because the coefficient of x squared here is 2. So this is the kind of thing that you could get as a trick question in a multiple choice. They could give you this as the equation and ask you to find the coordinates of the center or to find the radius. Alright? So anytime you have a situation like this where the coefficients of x squared and y squared are not 1, you have to do the division first. And then when you come here now, here is where you could see that if PQ is the center, right, and I'm changing the color of the ink just for emphasis. If PQ is the center, now you could see here that minus 2p is equal to minus 19 and 2. And you could say that minus 2q, let me see what you put in that. Minus 2q is equal to, okay, I'm rubbing it off here now because you get the point. Alright? What we had in green there is not what we're going to do. What we have in orange here is what we could do. So now we could say minus 2p is equal to minus 19 over 2 and minus 2q is equal to 17 over 2. And with that now, we could say that starting from here, p is equal to minus 19 over 2 divided by minus 2. So p is equal to 19 over 4. Yeah, you realize what I do there? I just give you the answer because that must be doing. So in other words, to be able to jump from here to here, I'm giving you a visual frame of reference to see the level of arithmetic, to see the level of algebra that we're moving towards. This is add maths, this is not maths. Good? And similarly over here, minus 2q is equal to plus 17 over 2. So q is equal to minus 17 over 4 because it's 17 over 2 divided by minus 2. So now we can say that the coordinates of the center of this circle in red would be minus 19 over 4, plus 19 over 4, minus 17 over 4. Alright, so in other words, at the level of add maths, do not go in expecting the center to always be 6, 7 or 3, 2 or minus 1, 5. No. sometimes the center is a fraction. All right, and you had to be prepared to deal with this kind of arithmetic here. You jump from here to here, you jump from here to here. This is add maths, not maths. All right, so that is what we would get if we had to deal with this circle. So let me complete the thing by finding the radius now. All right, we remember that with the general form, what it was. Hold on, I had to kind of get back into this thing here now. The general form was p squared, the root of p squared plus q squared minus k squared is equal to r or something like that. The k, big constant, is equal to the p squared plus q squared minus r squared. Right, that's what it was. Right, because the r squared was on this side and we brought it across. So we want to find the radius of this circle here in red. All right, so k is 60. That's the overall constant. Sorry, I used the wrong equation. The k is minus 45 on 2 here. Right, so minus 45 on 2 is equal to what? P squared. We already established that p is 19 over 4. 19 over 4 squared. And we established that q is minus 17 over 4 squared minus r squared. Alright, so we're going to rub off this middle section here in red. Alright, because we already have the equation of the circle there. You can always rewind the video if you need to. So minus 45 over 2 is equal to 19 squared is 361 over 16 plus 289 over 16 minus r squared. Alright, so we can rub off this now. Alright, you notice the algebra there, right? 19 squared, 361. If you need the calculator, fine, but again, as shown at the level we are operating at now. 17 squared is 289. So what I would do here now is make all the denominators equal to 16. So 2 by 8 is 16, 45 by 8 is how much? 45 by 2 is 90. 90 by 4 is 360. So 45 by 4. Sorry. 45 by 2 is 90. 90 by 4 is 360. So 2 by 4 is 8. 45 by 8 is 360. Alright. So this would be the same thing as minus 360 over 16 is equal to 361 over 16 plus 289 over 16 minus, and we could say, just for the sake of argument, 16r squared over 16. If we do that, it will allow us now to remove all the denominators and do arithmetic just at the level of the numerator. So we now have minus 360 is equal to 361 plus 289 plus r squared. So this plus this is how much? Let me see now. 361 to 89. 9 and 1 is 10, 6 and 8 is 14, and 1 15, 3 and 5 and 1 6. Alright. So minus 360 is equal to 650 plus r squared. Yeah? So I'm going to chuck it up in the corner here now, just for the sake of spatial consideration. Alright? And this is the advantage when you're using the big board. We could just go across. Yeah? So 650 minus 360 is equal to r squared. So this would be what? 290. 290 is equal to r squared. 360 and 300 is 660, right? So therefore r is equal to the square root of 290. Alright? Which we can leave it like that in third form, which if I can break it down, let me see. The root of 290 is equal to 17.02. Okay, 17.02. 17.03 equals 17.03. Right? Just for the sake of explanation, but normally at the level of ADMATS, we will leave the radius as a third. That is what we would normally do. For mathematical considerations, in terms of just being able to see it, for now, we express it like that. So, we get 2 in 1, basically, right? Because in the course of explaining this, I just pick a random circle, and then we run through the procedure to find the radius. Sorry, it's to find the coordinates of the center and to find the radius. So I get a little bit of revision there. So now back to the original matter at hand, which was to switch from the standard form, from the general form to the standard form. Reminder that you could only do all of them things that we just did if the equation is expressed in a form where the coefficient of x squared and y squared is equal to 1 in both instances. Good? So now that we established that, we could proceed as before, where we just want to express this in standard form. So remember, we're completing the square, right? So we do that as follows. Right, we had to switch up the colors and thing. So the first thing you do, just as I would have done in the general case a couple of videos ago, you bring all the x's together, you bring all the y's together. So you would have x squared minus 12x, right, plus y squared minus 14y, and you have the constant over here. Alright? You complete the square on this. Alright? This will be x minus 6, half the coefficient of x squared minus 6 squared. Right? This would be y minus half the coefficient of y squared minus 7 squared plus 60 is equal to 0. So you're starting to see the 36 and the 49 that we would have had originally starting to take shape. Right? It's really not as complex as it sounds. You know. The only really complex thing here is if we don't have the numbers looking as sexy as these numbers here. That is something you had to get yourself used to by practice. So the next step here would now be what? X minus 6 squared minus 36 plus y minus 7 squared minus 49 plus 60 is equal to 0. Right. So at this stage, we can start bringing the x minus 6 squared and the x minus 7 squared together, so we can start to make it look like the standard form. All right. So it will now be x minus 6 squared plus y minus 7 squared. Yeah. Minus 36 minus 49 is minus 85. All right. I will leave that there just for the sake of explanation. Minus 85 plus 60 is equal to 0. So we have one line here and one line here. All right. I could squeeze that in. So you'll have now x minus 6 squared plus y minus 7 squared minus 25 is equal to 0. Problem done right there. Alright, so that your final answer, and I'm going to switch up the colors now, the final answer will be, no choice at all, x minus 6 squared plus y minus 7 squared. You bring the minus 25 and I carry it across there. You know that 25 is the same thing as 5 squared, and that's the equation. So x minus 6 squared plus y minus 7 squared is equal to 5 squared. Alright? So your center is 6, 7, and your radius is 5. And that's it, you know. That is it. Alright? So in doing the addendum, the part that we left out, we also inadvertently got the opportunity to do a little extra revision. Alright, so now the ball is in your court, just as I would have been emphasizing in the previous video, video previous to this. So I want to take the opportunity to encourage you again. Take the thing really seriously, because the AdMath syllabus is going to get more complicated from this point on. After equation of a circle, you're dealing with radians. Alright? After radians, you're dealing with trigonometry. Alright? And after that, I will go back to the vectors. So that is what we're looking at in terms of section 2 in the CSEC AdMath syllabus. Alright? So as always, take care, keep good, enjoy the AdMaths, really enjoy it. You had to really put in the work to really enjoy it. Alright? It mightn't always be fun, but eventually you'll get to a point where you will start to enjoy it, but you had to put in the work. It might sound counterintuitive. You know, we have this idea that fun is just about pleasure. No, fun is not always about pleasure. Sometimes fun is work. Sometimes work is fun. Sometimes you had to put in a certain quantity and a certain quality of work before you get to the point where it starts to become pleasurable. So I wanted to keep that in mind. It might not always be pleasurable at the start, but the pleasure will come a little later if you're willing to go through the grind at the beginning. Alright? So, looking out to see you in the next video.